Hi everybody, I wanted to look at a question that a student had emailed me about earlier. So this is on page 646 of your textbook. Remember we're using the second edition TRO chemistry text, which is atoms first, not a molecular approach. This is a conceptual connection for chapter 15. We are just beginning to learn about equilibria. So the question states, the reaction A22B, it's an equilibrium, has an equilibrium constant of K equals 0.010. What is the equilibrium constant for the reaction B in equilibria with 1/2 A? And so what's really neat is that if we know one equilibrium constant for a reaction, like this one here, we know the equilibrium constant for this reaction. This reaction looks pretty similar, so we can manipulate this reaction and its equilibrium constant in order to figure out the new equilibrium constant. And why is this useful? Well, let's say I'm running a reaction and doing some research, and I can't find the equilibrium constant in the literature. So I'm not even sure if this reaction will favor products or if it would favor reactants. Well, I can look up other literature, equilibrium constants for specific reactions that maybe I can manipulate in order to determine theoretically what the equilibrium constant of the reaction I'm trying to run in the laboratory would be. So if it's going to favor products, then obviously I feel pretty good about it. If it favors reactants, then I may need to consider my reaction conditions. But anyway, so that's the reason why this would be useful for us in the grand scheme of things. So why should we care kind of question you should always be asking yourself. So it looks like when I have the original reaction that was given to me, the one that we have the literature equilibrium constant for, it appears I need to reverse it in order to look like the new reaction that I want to study in the laboratory. So my first observation is I would need to reverse it. Now, like I said in my online lectures in chapter 15, make sure you distinguish between the rules you would have learned in first semester general chemistry of Hess's law. For enthalpy, like if you reverse a reaction, you would change the sign of enthalpy and so on and so forth. It's different than how we manipulate the equilibrium constant. So if we were to reverse the reaction, then we take the equilibrium constant and we inverse it. And so that's the first order of business. And you can do these in different order. I just decided to reverse it first. If you decide to multiply it by 1/2 first, that's okay as well, which is the next thing we would need to do. If we want it to look like, so now if it is reversed, it looks like this. It looks like we would need to multiply by 1/2 in order for it to look like the desired reaction that I'm trying to study. So multiply by 1/2. So if you multiply by 1/2, then for equilibrium constants, you raise it to that power. So it would be the equilibrium constant raised to that power. And rather than Hess's law for enthalpy, you would multiply the enthalpy by 1/2. So like I said, review over Hess's law, because I think that's probably stored in your long-term memory, and make sure you distinguish it between the rules of Hess's law versus the rules of manipulating equilibrium constants. All right, so we have a plan of attack. We'll reverse it, so we'll raise the equilibrium constant, and we'll raise it to the -1 or inverse it. And then we'll multiply the reaction by 1/2 to get the desired reaction that we're studying. And so therefore we will raise the equilibrium constant to 1/2. So first things first, the original And let me just label, if I say this is the first, well, we already labeled it 1 and 2. And so the original k was equal to 0.010. And then if I wanted to figure out, well, after the first manipulation of reversing it, I'm going to raise this to the -1, or take the inverse of it, which is 100. And then the second manipulation we do is multiply the reaction by 1/2. And so we raise that 100 to the 1/2 power, and that's where you would get 10. So the equilibrium constant for the reaction that I want to study in the laboratory is 10. Does it favor products or does it favor reactants? It favors products, right? There should be 10 times the amount of products as reactants. Because remember, equilibrium constants are equal to products over reactants. And so anything greater than 1 indicates that it favors products more. So in this case here, this tells us that products are 10 times the concentration as you would find the reactants. Obviously, if you have an equilibrium constant of 1 times 10 to the 5th, then you have primarily products in there, right? So yeah, hopefully this helps with manipulating equilibrium constants. There may be multiple steps you have to take to get to the final equilibrium constant. It doesn't really matter the order you take the steps, but just be consistent. So once you've calculated the first step, you carry that on with the second step and manipulate that number. You don't want to keep going back to the original equilibrium constant if you've already changed it. Hope this helps. If you have any questions, let me know.